I am not really going to talk too much about tech, because I feel like it's so easy to find information about technologies. I'm going to talk about actually working at a place with technology. And I feel like when I didn't really know what the audience was going to be, but I feel like when I was a student, I heard the least about that and the most about technologies. So we're going to talk about just discovering problems at your company and creating value from those problems. So value is an interesting thing. And I think when I left full stack, my thought on it was, I should write good code. Like if I go somewhere and I write great code and I know all the cool tools, which at the time was Angular for me, but React or whatever it is for you guys, like I'm going to be great. And my company is going to love me. And I think the slow realization for me was that Scrum kind of removes your ability to make a big difference unless you go out of your way. You get tickets, they're very specific in what they want. You can write great code, 100% unit tested, it's hard to get attention. So the way I look at value now is important to describe as a separation between programming and engineering. Programming is this process of writing code. I'm positive everyone in the room can do it, mostly, I think, except for like 2 people. And then engineering is actually going somewhere and solving problems, right? Taking these things that companies need you to solve and taking them from 0 to 100. So I'm going to give you this example of a business need, which is that there's some endpoint we have to attach to a button. So this is one way. And I was waiting for the groan of the class since I didn't use any frameworks here, and it's all like native stuff from the browser. But this is one way we could do it. And you can see I wrote it in form 1, and then there's like, the font color should be brighter, but there's form 2. And we would just have to do this in every single form. This kind of, at least for me, is not great, right? So then we're like, OK, I don't really like this. I think we'll agree as a class there's better we could all do. So we get a little better. I introduced jQuery. We all love jQuery, right? So I've introduced like 1 level up in abstraction. And I'm like, look, I got rid of all this native stuff. It grabs the elements really well. Like, let's call it a day. But we still haven't really like dried it up at all. So OK, we dry it up. We write this function. It uses jQuery. I'm trying to like remove all the abstractions. So now in each form, we can kind of like introduce this function. And maybe we're OK with this. And I think it's important to state, like I could have picked any library. Whatever the coolest tech is right now, Axios or whatever the cool kids are using, like we can bring that in. But that's not the point. The point is that we didn't really solve the actual problem. The problem was nothing to do with the code we had to write. It was about the fact that you had to write that code. In a really good system, if someone asks you to change an endpoint on a button, you shouldn't have to write code. Honestly, I don't even think that's worth an engineer's time, is my stance at this point in my career. I think you should be writing UI that can be configured by someone like the project manager. So the problem is, it's not about the buttons and the endpoints. It's about, we didn't solve this non-technical problem without forcing 6-figure engineers to go in and change strings, right? That's a waste of your time. It's a waste of my time. It's a waste of everyone's time. So I'm about to show you like the worst wireframe you've ever seen. Right here. So this is my wireframe. And this looks like, you're like, Elliot, you're smoking something. I might be, but that's not the point. Like the point is, this actually takes us to a whole different place. Every single time someone needs a button to do a different thing, they can do it. I don't do it anymore. I wrote a thing. You can pick a button. You can pick what it hits. You can pick what it sends. That's all it does, right? This works for every button across the entire application. Every single ticket you're ever going to get is no longer yours. You get to just deflect it. You get to say, no, that's on you, Jim. Like, you can go do that. And that's the real value, right? We could talk day in and day out about what code should I use, what framework should I use, how should I solve this. None of that's really important to a company. What a company wants is for no one to be taking tickets where you change strings. Now, this is clearly a hard solution. Like, me showing you a mock-up white thing is not showing you the complexity of this, but it's very doable. I've worked at 3 companies that all had this ability. This is kind of where you get after you've done too many of these bad tickets. And I think kind of like what I'm hoping to show you here is that nothing about that had to do with code. It had to do with rethinking the problem. The problem wasn't changing an endpoint. The problem was having to have engineers change them in the first place. So all we're going to do is look at a couple other cases I've seen, and I have to say unnamed companies because of my contract with my current company. So I can't tell you where anything is, but you can just look me up on LinkedIn, so it doesn't really matter. So that was a trivial problem, right? But they do get more complex. So to start, let's talk about like how do we find these things? Like that was a pretty easy one. You threw me a really easy curveball there. Like how do we find these problems in a real organization? And I tend to think that there's a couple key things we'll always see. One, it's repetitive. Every sprint, every month, you're getting a ticket saying like, go and change this input field, or go update this component, or go remove that prop, or go ES7ify that thing. Like these tasks are things you'll hear every 2 weeks. Every engineer in your org is going to do. That thing needs to be killed. Whatever that thing is, there's a better way to do it. This solution to most tough problems can be explained non-technically. The kind of problems you should be targeting are things you could explain out loud. Like, hey, that button should be able to be configured by you. That was our first one, right? That's a very straightforward thing. Buzzwords. Don't do it. Don't fall in the trap of like going somewhere and saying, we'll solve this problem with TypeScript. Just you wait. That integration's coming. We'll solve this with GraphQL. There will be a middle layer. It'll sort everything out with our API. Don't be that person. Great technologies existed in like the 60s and the 70s. Like it's not a new tool that's going to solve it. It's a new way of thinking about the problem. If something is really consuming developer time, and I have some funny ones, most of them have to do with developers writing raw YAML, yet another markup language. Like literally, I worked at this company where they had people writing JSON files that were like 1,000 lines long to configure things. I was like, something about this process doesn't make a lot of sense, does it? Like, we should probably change this. That would mean you dislike it. If everyone dislikes doing this task, you should probably figure out a different way of doing it. And then the final thing is kind of like the mindlessness, and I will point a finger at Scrum here, which is like when you start getting Jira tickets or Trello tickets or whatever your org uses, like you stop thinking about what it is you're solving a lot. You're just like, I'm gonna beat this thing and move it to done, like, yay, I get my paycheck in 2 weeks. Like, that's kind of not how you want to deal with this. So let's leave all this abstract nonsense behind. And I think I made 2 cases. I wrote this all today. So first is microservices. This, I'll bet a quarter of the room, if you're employed, has dealt with this. You're at some company. Monoliths are awful. They're such garbage. We all hate it. Microservices are the future. We're going to move to them today. So we start the journey. We're on our way to microservices. And we make this wireframe. We're like, here's how this is going to work. So there's going to be all these microservices. We're going to have a team on MS1, a team on MS2, a team on MS3. We're going to have some front-end guys building a spa over here and some front-end guys over here. You're like, OK, that's 5 different Scrum teams right there. And there's a lot of arrows everywhere. They're pretty ugly, but they're there. And you can imagine that maybe there's a problem that happens here. And the problem is that when you have 5 different teams building 5 different things that all have to interact in a development environment, when one person breaks a thing, everybody falls apart, right? Every single team can't work in a development environment if someone deploys a bad build. This is the common problem of microservice, is you have 5 different repos. You're not all monitoring all 5. In a monolith, you all are all monitoring one code base. So this happened at a company I was at. And I'm not kidding, whenever this would happen, like someone would deploy a bad build, I'm jokingly calling them like, I don't even remember, some team breaks a lot. But whenever they would break one of these microservices, the rest of the company would walk next door and go to the bar for like 2-3 hours. We would just be like, all right, we'll just wait for them to sort that out. And you can imagine that this is like not something our management layer liked particularly. Like they kind of quickly figured out like whatever's going on here we need to fix. So someone decided that the solution had nothing to do with microservices. This was a development environment problem. Like we couldn't develop because some team was not having quality control stuff and like, yeah, there's these like meta solutions like let's just figure out all of us having unit testing and CI. Like you can go have those conversations at an organization. That'll take like 4 years. So someone said, why don't we just do this? Let's write a little service, tiny. I think it was in Node. And they said, we'll just add it to every single microservice or front end deployed. And what it does is every time they make a request, it goes through it. It's a little proxy. When the response comes back, if it's successful, we'll just cache it. If it fails, we'll return the last cache we have. If there's no cache, we will attempt to randomly generate data, which for the most part worked. Like, it's a pretty bad solution, but it was fun. They were just using like Faker. It worked for like 95% of stuff. And it's like, in your head, you're like, that can't really be the solution. But it really worked. Because someone would deploy a bad build, and what would happen is like we'd still be getting responses from that good build they had like 2 weeks ago. Like, the only downside of this was teams putting out bad builds weren't really noticing they were putting out bad builds. They're just like, look, it's all working. It must be good. But this saved like the company so much money. We weren't at the bar for like 3 hours every day. We weren't all like at each other's throats. Like, we could all develop like in ease. And that's kind of the dream of microservices, right? Like, the dream of microservices is that each team can build in isolation, and we could be writing in like Go or Ruby or whatever, and like nobody cares as long as we follow some contract. And I'm going to say yay jokingly, because that sounds terrifying to me at this point in my career. Like, if everyone's on a different stack, you're in for your own kind of trouble. But it solved the problem we had at the time. So another problem I saw, and I think this is very common, is UI building is taking too long. You're, company B, and you want to build Charmander 2.0, and you're like, we're going to give everyone all the big features they've always been asking for. So they get like 5 different teams, and they tell each team, like, go out there, go build me org structures, and you go build me like automating cars picking up the managers of that company that pays us. Like, and all these teams run off, and they're building these things. But the issue is that even if you're sharing like components and you're really cool and you use React and you've got some like component library, like each team's gonna have a designer and they might choose to use those components different ways. So you end up with like these 2 screens that like look different at first, but like they're actually pretty similar, right? Like, we've got a drawer and an app bar, we've got a drawer and an app bar, and we've got like some cards and we've got some cards. Like, these are really the same almost application. Like, they have different colors and icons, and like the cards have different widths and are dealing with grids differently. Like, it's pretty much the same thing. And most people at this point are like, okay, well, maybe we should have built like a shell. Like, maybe we should have built like a drawer and the app bar like the same for both people. But actually, this isn't a programming solution. This is a design solution. And it has a name. It's called Design Systems. And what this is that instead of engineers trying to figure this out, the solution since like 2017 has been turn around on your designers and say, like, get your shit together. Like, start building things that are consistent across all features. Like, every feature uses the same drawer, and drawers are for navigating. And every team uses the same modal, and modals are for submission and editing. And every team uses a dashboard, and dashboards are for viewing, and app bars are for settings. And when you set these rules with design, now you can build 4 components, right? Maybe they're configured. Like, God forbid you have to pass in some props. But like, you save yourself all this time of running around and everyone trying to like outdo each other and build fancier components and submit into some component library. And of all of these things I've spoken about, none of them have really involved coding. Like, each of these is taking a step back and saying, like, how do I actually provide value to my company outside of like writing that really cool one-liner, right? And I think that that is all I want to sell you today, is that it's really important to take a step back out of Scrum and look at the things you're actually trying to do that deliver